Welcome to Equations Part 3. Starting now, you guys are going to solve things called a system of equations. And after Part 1 and Part 2 of equations, you should be able to handle this. Now, a system of equations just means we have two or more equations. And when you're asked to solve it or find the solution, we're looking for the xy point where they intersect on a graph. So we want to know, where do they hit each other? So when you're asked to solve a system, we want to know where they will intersect on a graph. So here's an example of a system of equations. I see two equations, and we're going to go ahead and look at what this looks like on a graph, and then we'll figure out how we're going to solve this. So in Desmos, I'm just going to type in the two equations, y equals 5x minus 13, and y equals negative 3x plus 11. And you see that we see both lines over here, graphed in the coordinate grid. And right here, we see the intersection. Now, that is the answer. The solution to a system of equations is where they intersect. So I know my answer is 3, 2, but we have to figure out as good mathematicians, not only how to use the graph, but how to get there by hand. So the way we can do this first is something called substitution. When you're solving with substitution, you need one equation where one variable is isolated. If you're going to use this strategy, you need one equation where one variable is already isolated. Now in these, both of the equations already have nice y alone, totally isolated. So what you can do here is circle one of the y's that's isolated and box what it's equal to. Because now, if we know y is equal to everything in this box, we can take this box and swap it out, substitute it anywhere I see y in the other problem. So I circled y, I boxed what it's equal to, and now I can go trade spots with the y down here. So I can make this look like 5x minus 13 equals negative 3x plus 11. Since I know y is the same thing as this, I can trade places where I see y in the other equation. So I swapped out here, then I kept equals negative 3x plus 11. Now this should look like a problem that you solved in Equations Part 2. I see variables on both sides. I need to get them to the same side. So I'll add that 3x to both sides. Make sure you combine your like terms. Since this has regular x, I didn't put it with the 13. I put it with the 5x. 5x plus 3x is 8x. We haven't touched that minus 13. Equals, we haven't touched that positive 11. Now I'm solving here. I need to get rid of the 8 and the negative 13. Keep the closer number till the end. So I'll add the 13 and get 8x is equal to 24. 8x is multiplication, so the opposite is division. And so we'll get that x is equal to 3. And that's exactly what the graph showed us, that x was 3. Remember, the first number is always x in the coordinate grid. But we're not done unless you have both x and y. So we have our x answer. We're going to go back to the original equations now to get our y answer. Now it doesn't matter which equation you chose. So I'm going to take this one up here and write it to the side. Y equals 5x minus 13. Now I'm going to take my answer from the first part of the problem and substitute it in where I see x up here. I'm going to use parentheses to keep it organized. PEMDAS says 5 times 3 is 15. 15 minus 13 is 2. And as your final step, you should always write your answer as your x, comma, your y. And that's your final answer, which is exactly what we already got on the graph. So I see I have two equations, so I know I have a system, and my solution is going to be the x and the y point where they intersect if we graph it. Now, I want us to try and use substitution, and we need one equation where one variable is isolated. Once again, we already have two different options here. I'm going to use this option. Circle one of the isolated variables and box whatever it's equal to. Now you're allowed to take whatever you boxed and swap it out with any y you see up in the other equation. So I circled this y and boxed what it's equal to. So now I can go trade spots with the y in the other equation. So instead of y, I'm plugging in everything in the box. So I just took everything and replaced y, and that's still equal to negative 4x minus 9. I circled one isolated variable, I boxed what it's equal to, and I can go trade spots. And now we can solve. If that's negative 4x, I'm going to add it to get my variables on the same side. Making sure if this has regular x, I find the regular x on the other side. Negative 2x plus 4x is 2x. Don't forget that's a negative 7 there, so that negative should come down with it. Same thing, that's negative 9, so don't lose track of that negative, those negatives that come out front. I have the 2 and the negative 7 to get rid of. Keep the close number till the end. The opposite here will be adding 7. So we'll get 2x is equal, negative 9 plus 7 is negative 2. 2x is multiplication, so the opposite is division. Anything divided by itself is 1, and when one number is negative, the answer is negative. But remember, we're not done until we have an answer for both x and y. So we have x. In order to get the y value, we go back and we choose one of the original equations and plug in our answer for x. So I'll take this bottom equation, y equals negative 2x minus 7. And now I'll plug in my answer of x equals negative 1. So where x used to be, I'm going to make that a parentheses. And now I'll be able to put that negative 1 there. Negative 2 times negative 1 is positive 2. 2 minus 7 is negative 5. And you always write your final answer as your x, comma, your y. So your x, comma, the y. And we're done.